All right, welcome back. And in this video, we will be talking about page 7, but I want to highlight something here, literally, that is at the bottom of this page that I kind of overlooked last time. It's actually really weird to draw angles that are greater than one full rotation, either positive or negative. That's part of why it's so important to know these angles that we filled in the circle, because they're the ones you're going to draw most of the time. You draw those, and then sometimes you do the loopy thing around. More often than not, you just think like, where would this end up? And then you work with that. So the reason for that is that every angle bigger than 360 degrees or bigger than 2 pi is just going to be coterminal. It's going to end in the same place as an angle that's between 0 and 2 pi or 0 and 360, depending on what you're working with. So coterminal angles save us from having to really deal with angles that are bigger than 360 or bigger than 2 pi. And the way that we deal with that is we just kind of like figure out, is it coterminal? And if so, what is it coterminal to? So coterminal angles are angles that differ by some integer multiple. So the integer multiple is really important. Like it can't just be 1.3 times 2 pi. It doesn't make any sense. It's got to be a full circle. And a full circle is 2 pi or it's 360. So they have to be an integer multiple. So the symbol for integers are, so it's a z. So here's how you're gonna draw that. Let me zoom way in here. You're gonna go like this, right? So you basically draw a 7, but it's got a tooth. And now you're gonna go like this. And then close it off. That's how you're gonna do it. Let me do it again. Ready? So it's there. There. Do that. That's going to look perfect. This is the symbol for integers. And we'll come back to that. Like, it's going to be more important than you realize. So integers. All right, so let's try to show that these are coterminal. So I need to show that they differ by some multiple of 360 if they're in degrees. So the easiest way to probably do that, I'm going to take 1090, I'm going to subtract 10, and then I'm going to divide by 360 and see what I get. If I get an integer, then yes. If I don't get an integer, then no, they're not coterminal. So this will be 1080 divided by 360, which is 3. 3 is an element of the integers. So that's what we're going to do. So I'm not really happy with the way that worked out. Like this, boom, got it. Okay, an element of is an element of, and then this, the integers. Okay, so that's a big deal. Since 3 is an element of the integers, therefore 1090 and 10 degrees are coterminal. It's really all it takes. Now, if angles are coterminal, then you can kind of like write them in terms of each other. So for example, I could say that 1090 is equal to 10 degrees plus 3 times 360 degrees. Why is that helpful? Well, think about the drawings we were making on the previous page, right? I know that I need to go 360 degrees, 360 degrees, 360 degrees, another 10 degrees, and then that's going to be it. Basically, just draw 10 degrees, and you will get the coterminal picture. So these are coterminal. Let's try this. So it's same basic idea, except now, since we're in radians, we're going to divide by 2 pi. So I usually do the bigger minus the smaller. I'm going to do 43 pi over 7. Ooh, bad 7. 7 minus 15 pi over 7. Divide the whole thing by 2 pi. So what do I get here? I get 33/28 pi over, I'm going to say, so it's 7 times 2 pi, so 14 pi, which is 2. So I get just 2. 2 is an element of the integers. It's a little harder to do on the iPad than it is on paper, to be honest with you. Therefore, 43 pi over 7 and 15 pi over 7 are coterminal. Okay, but neither of those angles is between 0 and 2 pi. And usually you want an angle that's coterminal between 0 and 2 pi. What's the angle that's coterminal between 0 and 2 pi? Well, think about it. 2 pi is really just 14 pi over 7, which means that 15 pi over 7 minus 14 pi over 7. So I'm subtracting one full rotation from 15 pi over 7, gives me pi over 7. Both angles are coterminal to pi over 7. So both are coterminal to pi over 7. So is that a big deal? Kind of. I mean, they're coterminal to each other, but actually neither of them is the principal coterminal angle. The principal coterminal angle is pi over 7. So we could say that 15 pi over 7 is pi over 7 plus 2 pi, whereas 43 pi over 7 is pi over 7 plus, so I'd have to add 42 pi over 7. 42 pi over 7, 42 over 7 is 6, so 6 pi. 6 pi is 3 times 2 pi. So these are just things to think about. They're almost like number games that you kind of like play with yourself just to make sure that you can like work out how these things work. The more you think about it, the better off you'll be. All right, let's see if we can do, do I want to do these problems or do I want to like stop this and then start the next one? You know what, I'm gonna stop this and I will come back in the next video. We will finish this page. So I will see you there.